all know, Earth is 4.5 billion years old. In light of its immense age, 750 million years may not seem like a long time. However, a great deal can occur in such a long period of time. Earth was a drastically different world during the Cretaceous epoch, which occurred around 1 million years ago. Dinosaurs dominated the world, and flowering plants and trees had only just developed to live with conifers, ferns, cycads, as well as other groupings. It was hotter, muggier, and ice-free worldwide when these organisms evolved. Today's Earth is much colder than it was during the Cretaceous, and massive ice sheets and glaciers still cover much of the poles. But we also know that things are shifting. The study of dinosaurs, including distinct types, how they lived, their attributes, and what caused their mass extinction, has helped scientists get a better understanding of Earth and its history. Over the course of 165 million years, dinosaurs roamed the Earth. Then, suddenly, around 65 million years ago, they vanished. The dinosaurs' extended reign as top predators makes them undeniable triumphs in the history of Earth's biosphere. In this video, we will be talking about what Earth was like when dinosaurs were around. Stay with us till the end of the video to know exciting information. The land on Earth rolled into one contiguous area. When the first dinosaurs were on the scene in the late Triassic period of the Mesozoic era, some million years ago, all of Earth's land masses were still linked in one extensive continent, Pangaea. Whatever you may have seen in one section of Pangaea was probably pretty similar to whatever you may have seen in another. The environment was rather uniform over the globe, with the exception of the polar and equatorial regions, and there was less biodiversity among dinosaurs and other species than there would later be. Until the continents started to drift apart, diversity was unable to blossom to its full potential. Scientists agree that geographical barriers like oceans, mountains, and rivers are essential to the diversification and even speciation of all life forms because they limit the spread of genes across populations. Say you have one species of monkeys living in the Amazon basin, explains Carnegie geologist Christopher Beard, and the river changes course due to a flood. It's now a large barrier, difficult for the monkeys to cross. Though it wouldn't happen instantly, after another million years, the species wouldn't be able to mate efficiently. Over 195,000 years ago, as the Triassic era ended and the Jurassic era started, Pangaea started to split up, isolating living creatures in their regions and reducing the potential for genetic diversity. Isolation prompted divergence, producing the vast array of organisms now on Earth. Talk about variance. Beard keeps up. The Earth has never seen a more important splitting of land masses than what happened during the Age of Dinosaurs. During the Mesozoic era, which began in the Triassic and concluded in the Cretaceous, the supercontinent Pangaea gradually broke into the two continents Laurasia and Gondwana, and later into the 7 continents we recognize today. As it turns out, though, the 7 were all interconnected, traveling between the continents. When the continents were nearly in their present shape, around 75 to 80 million years ago, the Asia-dwelling ceratopsians, horned dinosaurs, and their relatives migrated into North America via the Bering Land Bridge. This land bridge connected Alaska and Siberia across the area now known as the Bering Strait. They came to North America from Asia. But why? No one knows for sure, but environmental shifts, resource competition, and a rise in food availability are plausible culprits in this range extension. However, after they reached North America, the ceratopsians prospered, expanded in number, and diverged genetically from their Asian ancestors. Since no other North American species were capable of effectively competing with ceratopsians, these newcomers quickly established themselves as the dominant species. However, ceratopsians weren't the only species to make the journey from Asia to North America. Fossil evidence suggests that other dinosaurs, as well as mammals, amphibians, and reptiles, all followed the same historical trajectory upon first colonizing the American continent, eventually becoming the dominant species in a wide variety of ecological niches. In our own backyard, Clovis man, an early hominid, crossed the land bridge between Asia and North America only about 12,000 years ago. Similarly, fossils found in the Moroccan Sahara by paleontologist Paul Sereno of the University of Chicago in 1995 suggest that dinosaurs crossed yet another land bridge on their way from the northern to the southern hemisphere. Sereno's finds in Africa shed light on a continent that was basically a mystery to dinosaurs before his time. Sereno made some educated guesses about what he could find in Africa based on what is known about the split of the continent. He hypothesized, for example, that any dinosaurs he came across would be closely linked to those of South America, which was joined to Africa in Gondwana. However, his discovery astonished not just him, but the entire field of paleontology. The shark-toothed reptile he discovered in the Sahara is connected to both the South American dinosaur Giganotosaurus carolini and the North American dinosaur. These genetic ties between North American and African dinosaurs suggest that their ancestors crossed an island chain or land bridge, perhaps the modern Strait of Gibraltar to get from Europe to Africa. The extinction. Dinosaurs of all sizes are just so unusual that people often assume they have been around for a very long time. By the end of the Triassic period, Earth was home to many different kinds of life, but the dinosaurs ruled the roost. Insectivorous and no bigger than a house mouse, most Mesozoic mammals lacked the diversity and abundance of modern mammals. Similarly to modern times, by the end of the Mesozoic era, there were three types of mammals: monotremes or egg-laying mammals, pouched mammals, and placental mammals, of which many are now extinct. Some experts think that the sudden appearance of angiosperms or flowering plant may have contributed to the extinction of the dinosaurs at the end of the Mesozoic. According to this theory, herbivorous dinosaurs may have been poisoned by angiosperms since these plants were not native to their diet and required a different digestive mechanism. The precipitous drop in herbivores meant there was less food available for carnivorous dinosaurs. Thus, they too felt the effects of the stress. There is no lack of alternative explanations for the extinction of the dinosaurs. The asteroid impact theory, which proposes that an asteroid smashed into the Gulf of Mexico 65 million years ago, creating the Chicxulub crater, is supported by a sizable scientific community. For weeks, the entire planet would have been pelted with hot, flying debris, which would have caused cloud cover and a shift in the weather. The idea states that the climatic circumstances caused the extinction of all dinosaurs, but allowed all other animal species to survive long enough to enter the Cenozoic. Due to the lack of competition from other terrestrial vertebrates after the extinction of the dinosaurs, mammals were able to gradually establish themselves as the top predators over a period of millions of years. However, despite the explosion of mammalian diversity at that time, numerous present mammalian species are remarkably similar to their dinosaur-era ancestors. Although dinosaurs have been extinct for 65 million years, living relatives can be seen in the plants and animals we see every day. They serve as constant reminders that the world of the dinosaurs is not as distant as we would have thought. One of the most common theories about why the age of dinosaurs ended. The reign of the dinosaurs lasted for 180 million years until an asteroid slammed into Earth 66 million years ago. According to physicist Luis Walter Alvarez and his geologist son Walter, a historic layer of iridium-rich clay was formed as a result of the collision. The asteroid's aftermath was largely responsible for the huge extinction at the end of the Mesozoic, and its devastation was massive and short-lived. For it to recover from a crash, it needed at least 30,000 years on Earth. This made it difficult, in the eyes of scientists, for life to return to the region. Even in the epicenter, where everyone expected things to be the worst, normalcy swiftly returned as it did everywhere else. Within 300,000 years, ecosystems everywhere on Earth began to flourish. After 10 million years, most of Earth's environmental niches were occupied by various forms of life that had evolved to fill them. The diversity of life was roughly the same as it had been before the disaster, even if the new mix looked drastically different. Will there be dinosaurs again in the year 2050? Do you own the 1993 smash hit, a situation similar to that depicted in Jurassic Park? Possible? Will we see dinosaurs again someday? The prospect of these enormous creatures returning to the wild excites and terrifies the majority of humans alike. The Earth has been home to terrifying beasts ever since it was created. Once abundant, dinosaurs became extinct millions of years ago. Speculations abound as to what Earth might be, like if dinosaurs hadn't gone extinct or were brought back to it at this time. This is due to dinosaurs being frequently depicted in popular culture. As for your query, the answer is yes. Dinosaurs will return by the year 2050. By 2050, scientists hope to have successfully resurrected dinosaurs. Perhaps you think this is the weirdest suggestion ever. In 2016, the Adam Smith Institute stated its firm belief that resurrecting extinct species would be possible by 2050. Founder and director Dr. Madsen Pyrie wrote a report in which he made the following claims. Dinosaurs can be revived by backbreeding with the help of flightless birds. Today's birds and dinosaurs share a shared ancestor. but current birds have very few, if any, anatomical similarities to their dinosaur forebears. DNA isolation techniques have made it feasible to restart the process of creating a live dinosaur. However, information about the time in which they lived would be stored deeply in their DNA, as Madsen puts it. In addition, dinosaurs' unique characteristics such as their toothed jaws, tails, and small forelimbs would be developed by selective breeding and gene technology. The concept of a real-life Jurassic Park is impressive, but it won't become a reality for at least a few decades. That's all for today. Thank you for watching. If you enjoyed the video, do like and subscribe to this channel.